and welcome back. This is another exciting edition of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 7.3 on the special products of polynomial. And the essential question here, well, it's a bunch of gobbledygook because those are the special products. We'll talk about these in a second, but they have names. The first one is the square of binomial. We'll talk about the square of a binomial pattern, and then we'll talk about the sum and difference pattern. Okay, so we'll do that in the video, and let's get started. Square of a binomial pattern. So what do we mean by a square of a binomial? Well, that means if I have a binomial and I square it, it will always come out to this pattern here. The square of the first term plus 2 times the product of the two terms plus the square of the last term. Okay, so I think this might be a little bit easier to demonstrate. Let's say I have x plus 3 times x plus 3. Okay, so this is a demonstration. This is really what? X plus 3 squared, right? Okay, so let's use our FOIL method, if you want to call it that. Let's multiply the two binomials together. X times x, x squared. X times 3, 3x. Now, this 3 times this x also gets me another 3x. And then finally, 3 times 3 gets me a 9. So I get x squared plus 6x plus 9. What do I have here? This x squared, it's the first term squared. The 9 is the last term squared. The 6x is the result of 3 times x, 3x, times 2, because I have 2 of them. That's where this 2 comes in. Okay, so that's the pattern. That's the pattern. And the only difference for a subtraction type of binomial is the middle term will be negative. Okay, so I can demonstrate this for you. We're going to do some examples here, but the problem with the examples is there's no in your notes there. You have to get those other notes into. You have to make sure you get these notes in there if you want to demonstrate what this is. You have to make sure you get this and this, because otherwise I'm just writing answers and it's not going to do you any good in your notes unless you write down what I say. 3x plus 4, quantity squared. I take the first term, square it. So that's going to be 9x squared. The middle term, this is plus, so the middle term would be positive. 3x times 4, 12x. 12x doubled, 24x. Then finally at the end, 4 squared is 16. That's it. That's it. That's what you have to do. For example B, 5x minus 2y quantity squared. I take the first term and I square it, so 25x squared. The middle term will be negative because this is negative. 5x times 2y is 10. 5 times 2 is 10. 10xy, doubled, 20xy. The last term's always positive because we're squaring, right? We're squaring a negative number, it comes out to be positive. 2y squared is 4y squared. Okay, so those are those examples. Then we have the other shortcut is the sum and difference pattern. So if I'm multiplying the sum of the same two, they're not really terms, but the same two values, I'm going to call them. The sum and the difference of the same two values, the result is this. We square the first term and subtract from it the square of the second term. We call this a difference of squares. We're going to get to that, I think, later in this chapter, but this idea of a difference of squares. Sometimes you'll call it the difference of two squares, but difference of squares. That's what this thing is called. So in this example, x plus 3 times x minus 3, take the first term, square it, x squared, minus, it's always a minus. Remember, I said it's the difference of squares. Take the second value, 3 and 3, and square it, you get 9. Okay, and this is where sometimes using the term or the word term gets a little confusing, because here the term is 3, here the term is -3. If we're talking about parts of the monomial, that's why I'm saying it's the sum and the difference of the same two values, so x and 3 in these two cases. Okay, so let's take a look at an example. Using the sum and difference pattern, find each product. T plus 5 times t minus 5. Well, that's going to be t squared minus 25. The first value, second value. First squaring t, squaring 5, 25. Always a subtraction. 3x plus y, 3x minus y. This will be 9x squared minus, always a minus, y squared. 9x squared minus y squared. Okay, so there's that example. And then using special product patterns and mental math. This only works in like certain cases here. And the idea is you're supposed to be able to do this in your head, but I'm going to kind of write out what I'm saying here. So first of all, this example works because 26 is what? 26 is 30 minus 4. 34 is 30 plus 4, right? And they say you're supposed to kind of like do this in your head, but like mental math, but you don't have to. What do I have here? I have the sum and the difference of the same two numbers. So I know this is 30 squared, which would be 900, minus 4 squared is 16. So that's going to be 884. I think the subtraction there was the hardest part. Anyways, that's how you could do something like this as kind of a quick way. Again, it only kind of works if you have this, if you have this kind of thing happening here. Anyways, that's it for this video. Thanks a lot, and have a great rest of your day. Goodbye.